Escape the forbidden forest. Penelope and her classmates are lost in the forbidden forest, and the devil is out to get them. But Penelope has magical powers that can build bridges across the dangerous river and take her friends to safety. The only bridges that can withstand the devil's wrath are the ones built between two similar trees in the forest. Given STR1 and STR2 denoting the order of trees on either side of the river, find the maximum number of bridges that Penelope can build and save everyone from the devil. So the only the bridges are the only one that built between two similar trees. Okay. So if we build a bridge and if it is built between two similar trees, then that will be the bridge which will be able to withstand the devil's wrath. Okay, so we need to find the maximum number of such bridges. Each tree in the forest, so star, hash, at, these are all different trees. So first example, star, at, hash, star, hash. So here star is common, so we can have a bridge there. Now we have an at, but there is no at, hash, at here. Now we have an hash, so here also we are having an hash, so we can also build a bridge there. Now there is star, there is no such string here, so the answer will be 2. So if we are having the same tree or the same character, okay, and then we will be building a bridge and we'll be finding. So the brute force way is we can just check like how many are having the same similarity, but we also need to know about the previous state, like the previously how much we have seen. So this is just a variation of longest common subsequence. Here we are just finding what is the largest length, largest length of the subsequence which is common. Here we can see that star and hash is common and its length is 2. So we just and we just need to find that length, because it's told like the only bridges that can withstand, this is the highlighting part here, the only bridges that can withstand the devil's wrath are the ones built between two similar trees, and we need to know how many bridges can be like built. So the bridges will be only built if we are having the similar trees. So we need to find the longest common subsequence, and it's a normal classic DP problem. I will explain this. So for that we will be making use of a 2D table, 2D DP table. Okay, and 1 2 3 4 1 2, let's have 1 2 3 4 1 2, let it be this 0 1 2, and this is S2, say. Okay, and this is 0 1 2 3 and 4. Okay, so that's the case, 0 1 2 3 0 1 2 3. So we are initializing, like say this is S2. So if the S2, this S2, this is the length. Okay, if the length of the S2 is 0 and both S1 is also 0, that means we are not having any common subsequence, so its length will be 0. Okay, so this DP table will be just storing the length, the longest common length that have been seen so far. So S2 is having a length 0, S1 is also having a length 0, so we are not seeing any length, we are not having any S1 or S2, so the longest common subsequence will be 0 there. Now S1's length is still 0, but S2 is having a character, any character, but at that case also there are no common thing, so we again have 0, similar to this one, this is also 0. And that's also the case when we are having S2 length as 0 and S1 is having several lengths. So here also we have 0 0 0 0. So this like all the first row and the first all the 0th row and the 0th column are initialized to 0 because there is no longest common subsequence with respect to those lengths. Now let's start from the S1, the first character of S1, okay, and the first character of S2. Let's check whether they are equal. So let me also write these characters is star at hash star, star at hash and star, and this is S1, this is S1, and let's have S2, which is I think star and hash. Okay, so these are the two things, two strings we are having, and each of these individual characters are trees, so we need to find the longest common subsequence. So we take S1 of 1, S2 of 1, so this character and this character, they are equal. If they are equal, we will be doing like, say, if dp of ij is our state, okay, at that time like we will be doing 1 plus dp of I minus 1 and j minus 1. So that's what we are doing. So these two characters are equal, so we will be just checking what is its dp of I minus 1 j minus 1. This is dp of 1 1, so what is its dp of I minus 1 j minus 1? It is 0 plus 1, so this value is 1 because we are having a common subsequence here. Like we clearly see that this star and this star is equal, so we are having a common subsequence of length 1. Okay, now S2 is at S1 is moves to the second, okay, we are having a length 2, so we will be taking its index like this character. So this one at and the star, they are not equal, so at that time if they are not equal, then our equation will be let me bring back there. Okay, then our equation will be max of dp of I minus 1 j or dp of I j minus 1. So that's our condition if it is not equal. So at and star is not equal, so we will be checking I minus 1 j. So I minus 1 j, that is this is dp of 1 2, so 0 2, or this one which is maximum, 1 is maximum. So if we consider like star at and star, just considering this, only these two are common and we are only having the longest common subsequence is of length 1, so that's what we store here. Now we move to the third S1 with a length of 3. What if we consider S1 with a length of 3? So we are considering this character, and S2 is with length 1, so we are still at here, and this is also not equal, so we will be considering max of dp of I minus 1 j and dp of ij minus 1, which is the maximum at. So again one more character we gets added. What is the longest common subsequence here? We clearly see like that this only these two stars are common, and that's of length 1, so it's still 1. Now we consider S1 of length 4, so we consider this star, okay, we consider this star. Now the characters are equal. So if the characters are equal, we will be considering dp of I minus 1 j minus 1 plus 1. So 0 plus 1 still 1. So this means like we are having here also a star, but still here we are having s1 of length 4 and s2 of length 1, but still only this is common. Even though we are having another star, does not like calculate, like we does not compare these two stars and increase the length. We need the common one. So this is the common one and we are having 1. So still the length is 1. Now we consider s2 of length 2. Now we are considering this one too. And let's start s1 from the beginning. Now we are considering s2 both of length 2. We are having star and hash. Now we are having star. So is this character is equal to star? No, it's not equal to star. So we will be taking max of this one or this one. This is the max, so 1. So that means like we are having let me take out some characters. So that means now we are considering s2 of length like star and hash, and we are considering s1 of length 1 just star, and we can clearly see that like these two are the common here. So still the length is 1. Now we move to at. We consider s1 of length 2. So is at and the character hash is equal? No, they are not equal. So again we consider the max from this one and max from this one. So the max is still 1. So and here also it's 1. So that means like we are considering this string star at and star hash. So only these two are equal. So still we are having the longest subsequence as 1. Now we have hash and this is also hash. Now these two are equal. So that means we need to consider from the I minus 1 j minus 1 position. That is from this position, this is 2 3. So we need to consider 1 2, which is this one. So 1 plus this character, so 2. That means like we are having a hash here. So now it's not the cases that we discussed earlier. Now we are having one common subsequence and another common. So this is of length 2. So star and hash are the common. So it's having a length 2 and we are storing that length 2. Now the last character star. Is star is equal to hash? No. So we will be taking 2 and 1 and its maximum. So 2 is the maximum. So whatever the value that we are getting here, that's the answer what we are looking for. So our answer will be, our final answer will be after filling up the DP table. Our answer will be DP of whatever be the length of S1 or S2. Like you can also take S1 here and S2 here. It's according to wish. I took like this. So according to this example that I drawn here, then here it will be DP of L2, where L2 is the length of S2 and L1. So this will be the answer that we will be returning. So here it's simple, like we just need to find the longest common substring. Let's try to code it. So as I told, let's have the lengths str1 dot length int length 2 is equal to str2 dot length. And since I mentioned here on the row I took S2 and on the columns I took S1, we can also take the other way around, and in either of those cases, like we will be getting longest common subsequence in the DP of L2 L1 or DP of L1 L2, whatever you are considering based on the row or column, and that will be the answer that we are looking for. So here let me continue with the way I explain here. So new int of this will be length 2 length 1. So first our DP table will be full 0. 0 0 0 0 how much character? 1 2 3 4 5, yeah. 0 0 0 0 0 0 0 0 0 0. So like this will be our table. So initially, like what we told was all the first row and the first column will be 0. So this is already 0, so we can just start from I is equal to 1. Okay, so it will be length 2 plus 1, length 1 plus 1. So now for int I is equal to 1, I less than or equal to length 1, or I am going the other way around, so length 2 I plus plus. For int j is equal to 1, j less than or equal to length 1, j plus plus. If s2 dot caret of I minus 1 is equal to s1 dot caret of j minus 1. So if the characters are equal, we are having a common. So we need to take dp of I j is equal to 1 plus dp of I minus 1 j minus 1. Else we will be taking the maximum that we see so far on the left and on the top. So else dp of ij will be mat dot max of dp of I minus 1 j comma dp of I j minus 1. Now we just simply return dp of length 2 length 1. So here our time complexity will be big O of length 1 into big O of length 2, and our space complexity, as we are making use of a dp table, it's of size length 1 into length 2. So our space complexity will be also big O of length 1 into length 2. So yeah, it's because it's str2 str1. Okay, we are getting 2. What if we give the other characters star hash? There is no common, so the answer must be 0. There are no common items, so the answer must be 0. It's getting as 0. Yes, we got it. Now like I mentioned, like we can do it the other way around also. Like we can take s1 on the row and s2 on the column. So what we need to do at that case means it will be length 1 plus 1, length 2 plus 1, and this will get adjusted then. Okay, then our table will look something similar to this one, like this. So here also, like this will be length 1, this will be length 2, this will be str1, this will be str2, and this will be length 1, length 2, and we will be getting the same. So it doesn't matter like whether you took s1 on the row, s2 on the column, or the other way. The logic is, if we find two characters are equal, then our state dp of ij will be 1 plus dp of I minus 1 j minus 1. Otherwise, if the characters are not equal, we need to take the maximum that we have seen so far from either from the left or the top, from the top. So it will be mat dot max of dp of I minus 1 j dp of ij minus 1. So this will pass all the test cases. So the space and time space complexity, we are making use of a dp table. So big O of length 1 into length 2, or length 2 into length 1, whatever it will be same, and the time complexity big O of length 1 into length 2.